So, if we are doing optimization modeling, we will need tools to create what if model or what if scenario to calculate the results of interest. We need to define the decision variables for input that is under our control that we can change, so that we will now identify the step in change that are possible. We should be able to define constraints and an objective, whether to maximize or minimize a particular relationship. Then we run the optimization for optimal value and do sensitivity analysis. To do this, we define constraints for limited resources, for physical condition, for policy variables. We need to understand dependence between output and input, which may be linear or non-linear. They will then run the optimization or multiple optimization with parameters that will vary. We assess and think about the results to understand different aspects of the result. There will be dual values, there will be sensitivity analysis. Then here we are talking of linear or non-linear model. So it depends on the mathematical function that the model follows. The general one is the linear, which is y is equal to a plus bx. A will be the intercept, b is the slope. When it is logarithmic, y equal to log, this is natural log of x. Polynomial of second order is quadratic, and you have ax squared plus bx plus c. Polynomial of higher order, we have x raised to that power. Then power function will be such like ax raised to power b. Exponential function, the x will be at the power. We've seen some of this under the Excel module, where we fit a model, draw scatter diagram, and try to fit a trend line that is compatible with the model. So this we need to understand and test for our data when we need to define relationship. Because if the relationship is exponential, for example, and we fit a linear, the error will be high, and then the prediction, a lot of the prediction will be wrong. So for example, exact trend line that we used before can fit various functions. If you have something like logarithmic, for example, y is equal to 13 ln x plus 39, for assuming we fit all this for a data, the logarithmic give r square 0.38, the power function give r square 0.39, exponential 0.66, polynomial of degree 2 0.9, polynomial of degree 3 0.93. These are the r square, which are coefficients of multiple determination. The higher the r square, the better the fit of the model. So this one that is having 0.93 r square is the best. Now assume that we did not try the different variability. If we stop at power function or linear is not even here. So if we start from the linear, we will just think that is what is applicable. If you want to find y here now, when x is 10, you need to first find natural log of 10, multiply it by 13 and add it to 39. But if it is here, you do 10 raised to power 0.0169 and now use the value to multiply 45.96. If we are here, you are going to do 0.021 multiplied by that 10. Then you now find the exponential of the result before you now multiply by 50. If it is polynomial here, that 10 will be raised to power 2 here, multiplied by 0.3. The same 10 will be multiplied by 2.4. Then we now do the arithmetic. The same thing here, 10 raised to power 3 multiplied by this value, 10 raised to power 2 multiplied by the coefficient, 10 multiplied by, then we now do the addition and subtraction as the case may be. So we need to take note and explore all possible model variation that is possible. Thank you.